Hi, this is Dean from SYX660. This is a video explaining how to set up an SYX660 series controller. There are a number of controllers in the family, 660, 661, 2, 3, 4. They're all set up the same, so you can follow the same procedure. So first of all, obviously we make sure the controller is correctly installed and powered with all the relevant inputs connected. But first of all, once the controller's set up with power, we need to log in at user 2. So to do that, we hold the escape key in for 5 seconds and we choose user 2 by turning the wheel and pressing the button, and then we enter the code 0, turn the wheel once to 1, 1, 1, 2, and then to enter that code we press the select button. Okay, so now we're logged in at user level 2. You can check the user level you're logged in at by holding in the escape key once more. And you can see that user 2 is no longer available and we get the option to log off. We don't need to do that, we're just going to press escape. Okay, so now what we do is we access the main setup or the main operating menu. And we have, if you've watched the other videos, especially the one setting up with the web browser, you'll see that there are these 5 categories. And in each category there is a setup function. So we choose overrides, and we choose switch, and we choose we choose the overrides, we choose switch, and we scroll down and choose setup. Here are the 2 options that we have to choose. So the first option is hot water extension feature. Do we want the hot water to be overridden into day mode when the heating day mode override switch has been activated? And we can choose enabled as default, or we can press the wheel and choose disabled if we do not want the hot water to follow that override. So we're going to leave that as set as enabled. The next option is auxiliary switch option. We press the wheel on auxiliary switch option, and we can turn the wheel then and select what is the mode of use for that auxiliary input. Now the auxiliary input is on terminals 29 and 30, and if we have a volt-free contact connected onto those 2 terminals, we can choose what feature or function it has, or override function it has on the controller. So the default mode is frost mode, so we would use that typically for a holiday switch. Hot water demand, which is the option we're going to choose today, this is where we have a control circuit wired into the SYX controller as a volt-free contact, where we monitor the primary circuit demand, and then once there is a demand proven by closing that contact, we then want to ramp up the boiler output so that it services the hot water demand. So I'm going to choose hot water demand shortly. And then the other option is summer mode, where we disable the heating in summer, but the controller automatically has a high ambient function which simulates the summer override function based upon outside air temperature. So the summer switch tends to be less used, so that's why we've got a few other options for this input. Underfloor demand is where we use the SYX controller. The pump output is used to enable underfloor heating manifolds, and we wait for the underfloor manifolds to send a heat demand back to the SYX controller before we open the VT valve and start the boilers to service the underfloor heating circuit. So that's a nice feature. So as discussed, we're going to choose hot water demand for this particular input. And that concludes the options that are available in the overrides menu. So we just press escape and escape and escape, and we're back to the top of the list. Now we do the same for the heating menu. We choose heating, we choose switch, and we turn the wheel down and go to the setup menu. In the setup menu we face a similar list of settings that we need to run through. So the heating mode for our application is an optimizer compensator. We have a number to choose from. If we press select onto that feature, we can choose night setback, which is something we would use for a permanently occupied building, something like a retirement home, where we only want to reduce the heating at night time. We don't want to turn the heating off. So that would be like a day-night setback function. Optimizer compensator is obviously the one we're going to use. What we have is a self-learning adaptive heating time function on the heating, and it will maintain that day temperature throughout the day, and it will optimum off should we have that feature enabled before the end of the day if we've got surplus heat capacity. Out of hours, we will return to a frost protection level, so the heating would technically be turned off, subject to going below frost conditions. Timed on off is slightly different to the optimum start. There is no optimum start capability, and out of hours the heating is returned to a frost condition, so we basically have more predictability about when the heating is going to start and stop. Some residential applications get a little bit disturbed by heating plants starting up at unexpected times of the day. So because they have such fast warm-up rates, sometimes the optimizer could be a little bit disconcerting for people who don't expect the heating to be running when they haven't programmed it. So timed on off is a feature for that. Optimizer only, this is where we use the pump output to start and stop plant based around an optimized start signal. It will turn on for optimum start, remain on for the rest of the day, and follow the optimum off if it's enabled. There is no control functionality with that application. It purely is an optimum start capability. And then finally there's an optimized Y-plan application for large domestic applications, where you have the traditional Y-plan arrangement for the heating system with the motorized valves and hot water arrangement, both sharing the boiler, but there is the option there of optimizing it if that's required. So anyway, we're going to choose optimizer compensator for our application. What we also then have next is VT set point, and we can choose whether it's adaptive or non-adaptive, adaptive or self-adaptive. This is basically room influence. So this is where we look at the room sensor, we look to see if it's above or below the current room set point, and we have an effect on the calculated flow temperature based upon a ratio. So if the room set point was 20 degrees and the current room temperature was 18 degrees, we would be in deficit of 2 degrees. So with the room influence ratio default setting being 3 degrees, the 2 degree deficit would be multiplied by the 3, and we would add 6 degrees to the current calculated flow set point. This provides some additional comfort and some additional boosted heating to the radiators, so that we get a little bit more faster reactivity to the deficit in space temperature. Okay, so we're going to choose self-adaptive. Optimum off currently is enabled, and we will leave it enabled. So this allows the heating to be switched off if there is surplus energy in the building that we can take advantage of before the end of occupancy. So the controller is monitoring not only the rate of rise for the controller, but also the rate of decline of heat when the heating is turned off, how quickly the building cools down. So if we understand the dynamics of how quickly the building cools down, if there is a surplus of heat before the end of occupancy, if we can maintain it within 1 degree of the energy set of the target set point by the end of occupancy, then we can utilize that, and we can switch the heating off early and obviously save some money for the client. HWS priority, if you have hot water plants serviced by the boilers, and the boilers are maybe a little bit undersized for heating the hot water jointly with a full demand of heating during the colder winter months, then we can take a decision to throttle back the heating supply and give priority to the hot water. And we can choose how we go about that by closing the valve down, or we can turn the heating pump off. So we choose which event we would like to do. Flow economy mode. This is a feature of the controller where it looks at the calculated flow set point and it's looking at the current room temperature. If they are within 7 degrees of each other, based upon the slope of the heating curve, if we end up with a calculated flow set point which is very close to the current room set point, then there's little point in running the heating plant to service that demand. So the controller will go into an economy mode, which is saving energy because there's little purpose of running the plant to service such a small demand. Optimizer adaptation, we'll come on to this when we talk about the optimizer low limit alarm. There's a separate video on that, but in this particular case we want the optimizer to remain adapted. We don't want to disable it at this stage. We want the optimizer always to be enabled wherever possible, and we should understand the system dynamics to make sure that the optimizer is working as efficiently as possible. We can monitor the optimizer performance on the SYX controller by going into the heating menu, into values, temperature control, and looking at the building warm-up rate. This is a factor that the controller calculates based around the current conditions and how the building is warming up based around the available heat supply into the building. This is a very important factor which we should understand about the controller, because this is essentially showing us how efficient the building is, and it's also showing us how the current heating plant is performing within the building. So we end up with a sensible relationship between the heat supply and the building efficiency, so we can see how buildings compare with each other on a day-to-day basis, and also seasonality as well has a massive effect. So sensor placement and also set points that we try to achieve with the plant will affect the building warm-up rate. Where there are situations that the set point is not achievable for technical reasons or through design reasons, then it may be a factor where we have to disable the adaptation, and this is the parameter that we would set to disabled should we need to do that, but we'll leave ours enabled. Okay, that concludes the heating menu. So we press escape, escape and escape, and we're back to the main menu again. All the other menus now are quite straightforward. So we choose hot water menu, we choose switch, we choose setup, and we have to decide if the hot water is linked to the boilers or it's independent, like a gas-fired water heater. In our case, because we're using the hot water demand system, this system is boiler linked. So I choose link option, turn the wheel, went down to boiler linked, and press set on boiler linked, and that's the function set. I'll just press escape, press escape, press escape, and now I'm back to the main menu again, and now I can set up the boilers. Press set on boilers and I choose switch, I turn the wheel, I come down to setup, and now I can see rotate boilers, number of boilers, and boiler pro used, and is the flow sensor used. So let's run through those. So number of boilers first, I'm going to set that to be 2 boilers. I can now set up whether I want those boilers to be rotated on a weekly basis. It may be the case you don't want to rotate them if the boilers are of different capacities or you have different efficiencies. You may want to prioritize one over the other, but we will enable the boilers in our particular case. We have a flow sensor used. It is the case that sometimes the controllers that we're replacing with an SYX controller may not have a boiler flow sensor. It is by far the most efficient way of operating your system for us to modulate the boilers. So if you can convince the client to have a boiler flow sensor fitted at the time of install, this will pay dividends down the road, because we can match the boiler load to suit the system load throughout the heating period of the year. So we can modulate the boilers to match the relevant demand from the system. Boiler Pro used is a feature of the controller where we have a 0 to 10 volt output, and we can send a 0 to 10 volt demand signal to a boiler step controller from the Boiler Pro range that we offer, as in SYX660. We have a number of Boiler Pro modules which can cater for different types of boiler and different types of loads that boilers can present to us. So 0 to 10 volt sequencers or high-low fire boilers, etc. So that will allow us to send a 0 to 10 volt signal to the Boiler Pro, and we have to select this option here to yes, so that we end up with the correct scaling of the 0 to 10 volt output to match that to a Boiler Pro. Okay. If you don't have a Boiler Pro selected, or you don't use a Boiler Pro, it won't matter whether that's set to yes or no, so you can just leave it as default. Okay, so that's the boiler setup. Press escape, escape, and back to the list again. Finally, we can set up the last option called connections. Press the wheel on connections and choose switch, and we choose setup. This is where we set up the use of the 0 to 10 volt output that the SYX controllers offer. There are three options. The first option is whether we use it for controlling the variable temperature valve as a 0 to 10 volt signal. The controller naturally offers a drive open or a drive close signal, which is the majority of products on the market that the SYX replaces. However, there is the opportunity to replace more sophisticated products with the SYX, where you're looking to offer a cost saving to the client, which means we can utilize a 0 to 10 volt drive straight out of the box without any settings needed. The 0 to 10 volt can also be used, as we've already discussed, it can be used to drive a Boiler Pro sequencer, in which case we would choose the boiler percentage option for the 0 to 10 volt output. And that could also be used to drive a boiler directly. We don't have to use a sequencer. That would only be for multiple boilers. If there was one boiler that could accept a 0 to 10 volt signal, we could drive that boiler directly, just using that as a demand signal. Equally, if the boiler is compatible with it, we could send a 0 to 10 volt signal as a boiler set point, where we can scale the 0 to 10 volt output to be reflective of the actual flow temperature demand. So that's another unique feature of the SYX product in this category of products on the market. So if we do choose boiler set point, we do need to be able to scale the output, and that's what we do in the values section in the setup menu. So we choose escape, 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 this time choose values, and this time we choose setup, and this is where we can scale the output. Where it says output, that's the current voltage reading. Set point low and the minimum voltage go hand in hand. This is where we set the expected set point minimum for the relevant voltage, and we also set the set point high with its relevant voltage. In terms of percentage, 100% would be 10 volts, 0% would be 0 volts. Okay. To finish up on connections, we also have sensor calibration, where if you identify that a sensor is a little bit inaccurate, you can apply an offset to the reading. It's a linear adjustment. It's a single point adjustment. So for example, the outside air sensor was reading ½ degree too high. We can knock that back by 0.5, and that will be a permanent offset onto that sensor as part of your final commissioning or maintenance of the product. Okay, and we didn't finish in switch, where we have pump changeover modules. If pump changeover modules are being used on the outputs to drive twin head pumps, it's important, one of the important features is that those modules are turned off as a demand signal in order for the lead pump to change over, subject to them being in fault. So for an automatic changeover, the module needs to have its demand signal removed for more than 15 seconds. If the SYX is in an application where the heating is 24/7, subject to some kind of economy mode, it could be like a retirement home or like a fire station where it's manned 24/7, we only relax the heating back, we don't actually turn it off, then we have to find a situation or engineer a situation where we actually remove the demand for the pumps for a short period of time, 15 seconds, so that the pumps can change over on the changeover modules. Okay, so that's what the pump changeover module menu will do. It will allow us to rotate weekly or daily, and that's what it does. It disrupts the pump demand signal for 15 seconds so that the pumps can change over. We're going to be leaving that is not used at the moment. Okay, so that concludes all of the menus that we need for the setup mode. So what I'd like to do now is take the opportunity to show you a few things that the controller can be used for in terms of helping you to commission the product. So the first thing I'd like to touch on would be just to escape out of the product, get back to the time and date, where we have the information button. We can press on the information button and choose terminal values, and this gives us a live display of all of the inputs and outputs on the controller, so we can identify if, for example, a particular item of plant isn't working. It could be a wiring issue, it could be a power supply issue, it could be a piece of equipment issue, but if the controller is asking it to run but the plant isn't actually running, you can focus your attention onto the item concerned rather than focusing too much about the controller. So it's a good point to start, is just look at the pins, see what the current condition is before you start to get too involved in trying to work out why things are or aren't working. Sensors, all the sensors should be reading, obviously the ones that are connected. For certain applications we need certain sensors connected, so just make sure that they're all wired in correctly. Some of the controllers types do have polarity sensitive sensors, so the SYX660 product, the sensor connections are polarity sensitive, so you must observe the correct connection of the sensors. All the other controller types are not polarity sensitive, and it doesn't matter if they are incorrectly wired. There's no damage you can control to the actual sensor inputs by wiring them around the wrong way. Obviously, just make sure that they're all working prior to powering up the controller's outputs in terms of the mains voltage signals. You don't want to make sure that all the wiring is correct before you permanently power up the device, especially with mains power on the outputs. So, okay. Next thing I'd like to show you is how to test the variable temperature valve. Again, we're still logged in at user level 2, and for that we can make a manual override adjustment. So we press the select button, we choose heating, we choose values, and we drop down onto the VT valve, and we press on the wheel on the VT valve and we choose manual override. Press the wheel on manual override and it gives us the option to put a value in there. So I don't know, just arbitrarily put 60%. The hand light has come on, and the outputs have started to drive the valve. We can then visually check the valve is driving the correct direction, make sure the valve is correctly allocated into the pipework, and then once we're satisfied that everything's okay, we can press the select button on the valve on the manual override parameter, and then we delete the value. We wait for the hand light must be extinguished before we'll get auto control. Okay, so that's complete. Press escape. Another nice feature of the SYX controller is the commissioning mode. Now, it's a common factor that a lot of heating controllers are installed during the summer months. This is where the plant is of no use, is in a maintainable condition, maintainable state, should we say. So during the summer months, most of the boiler houses are being refurbished or controls are being upgraded. So during those summer months, it's the last time of the year where we actually want to have the heating running. So we have to find a way of making the plant work so we can actually test the plant. So having the commissioning mode is really, really handy, because we don't have to over manipulate the controller to make it operate, because a heating controller will fight us trying to make it run in summertime. So the commissioning mode simulates a winter's day, and to put it into commissioning mode, you press the select button, you choose heating and switch, and you choose, in that list you then choose commissioning mode, and then you turn the commissioning mode on. The hand light will come on and the display will start to flash at you to say commissioning mode is active. Now what that actually does, if we come out of the switch function and go back into heating and choose values, and then look at temperature control, if we just scroll down the list of values there, the outside air temperature is now simulated as being 5 degrees, and the space temperature is now simulated as being 18 degrees. Now that means that the controller will think it's a very cold day, and it thinks it's cold in the room, and it will mean that the heating will come on, and it will try to achieve a set point of around about 70 degrees, depending upon what the current room temperature is. There you go, flow set point 70 degrees, and then we can see the valve modulate, we should see the boilers come on, we should start to see the controller start to control the flow temperature around 70 degrees. And that's a good way of proving that that particular circuit is then going to be fed with the flow temperature we expect into that particular zone of the building. So what I would then do is go and inspect the radiators in that circuit, make sure they're getting warm, especially warm where the room sensor is located. It's essential that the placement of the room sensor is in a heated location in order for the optimization to function correctly. And we want to make sure that those TRVs are turned up to maximum, and we want to make sure that that flow temperature is actually being sent and received at those radiator locations. Okay, that's about it for now. One other setting I just want to point out is the warming up rate of the heating system. So to get to that, we choose the switch, we choose heating, we choose values, we choose temperature control, and we just scroll down and we choose the warming up rate, building warm up rate. Hit the wheel on that, and you can see on this particular controller it's been set to 1, probably from a previous video that we've been preparing on this particular product. And this is where we set the building warm-up rate, and we can adjust that, and we can make the necessary changes to clear the building warm-up alarm, optimize a low limit alarm that we've discussed in a separate video. But this is where you can make the same change for the same reasons, and remove the alarm from the system as necessary.